Greetings to everyone. My name is Tibei Ying and my team members Liu Jingyi and Nor Madiha from Group 4 are going to present our traffic assignment. In this project, we have to identify the traffic issue on the selected location. My team has chosen the junction at Jalan Bukit Imbian and Jalan Bukit Imbian 14 because the junction is facing serious traffic congestions, especially during peak hours. The assignment also will involve doing an evaluation of traffic characteristics at the cross junction of Jalan Bukit Imbian 14. We will have a deeper grasp of the traffic parameters, including both macroscopic and microscopic parameters.
My name is Liu Jingyi. Now I would like to present about the geometrical data. For our project, this T-junction have three routes, which are route A, route B, and route C. Therefore, there are three directions that will come from the vehicles. According to the site observation, there is one lane in direction C, and there are two lanes for the straight movement and the one lane for giving way to the left movement in the directions A and B. In addition, we also have determined the route width by using the Google Map. Next, we also had determined the route width for each lane. First, for route C, the both lanes are the 4 meter. The width of two lanes for straight movement in route A and B is 8 meter. The width of the left movement for direction A is 4.5 meter and for direction B is 5 meter. Next, as we can see, there are three directions and each direction maximum have two movements. They are directed in different ways. Therefore, we mark as V1 until V6 for each movement. We also have determined the turning radius for V2, V4, V5, and V6. Since the route is assumed to be a flat route, therefore the grade of the route equal to 1. Moreover is traffic volume and the composition of data. First, the composition is the total number of particular type of vehicles in one direction divided by the total number of vehicles in that particular direction and multiply the 100%. Second is traffic flow, defined as the number of vehicles passing a specific reference point on a route section within a specified period of time. In our project, we had calculated the three types of flow. First is hourly flow rate. For each respective time interval, units is vehicle per hour. The hourly flow rate is equal to the number of vehicles in the 15-minute interval and multiplied by 4. Next is traffic flow. The unit is vehicle per hour. Traffic flow is equal to the total number of all vehicles in the one direction per hour. Last also as traffic flow, but the unit is PCU per hour. Traffic flow is the total number of the particular type of vehicles and multiplied by the respective PCU factor. So what is PCU? PCU is the passenger car unit. It's a metric used in transportation engineering to assess the traffic flow rate on a highway. The table shows the typical PCU value for the roadway. So in our case, we use the PCU factor as urban route for our T-junction. Last, we have calculated the three types of flow for each movement. Based on our data, we can conclude as the movement V3 is the highest rate of flow.
For traffic data, we can further discuss about the traffic flow of volume, speed, density or concentration at headway. First, we discuss about the traffic flow of volume. Flow is the rate at which vehicles pass a given point on the roadway and is normally given in terms of vehicle per hour. The count can be directional or all directions. There are four types of traffic flow, which are annual traffic, average daily traffic, average annual daily traffic, and hourly traffic. Table 3.1 clearly shows that Hourly traffic is the most suitable parameter to compute because it is utilized to construct traffic controls. In our project, we also compute the flow rate for each time interval based on the volume of the intervals. In this project, we observe every 15 minutes interval for 4 times. Density or concentration is the number of vehicles in a given length of roadway or lane in unit vehicle per hour. It is also a popular criterion for describing road performance. The density of traffic on the road can tell us how bad the congestion is. When the density reaches its maximum, the flow rate drops to zero, resulting in a traffic jam. We may calculate the density of traffic K using the formula below where Q is traffic flow and U is space mean speed. To compute traffic density, we first need to know the space mean speed, which can be estimated from the spot speed data we acquire on site using the following equation. Next, speed. Speed is defined as the distance traveled per unit time. The parameter is usually used to describe the quality of journey and the performance of the road network in accommodating traffic demand. There are 5 types of speed, which are spot speed, journey speed, running speed, time mean speed, and space mean speed. Spot speed is used to estimate the distribution of speeds of vehicles in the traffic stream at a particular position on the highway. This is done by recording the speeds of vehicles at the specified location. Journey speed is the effective speed of the vehicle on a journey between 2 points and is the distance between the 2 points divided by the total time taken for the vehicle to complete the journey including any stop time. The formula is the distance divided by the total journey time. Next, running speed. Running speed is the distance divided by running time. For example, total journey times minus the delays. Running time is the time that the vehicle is actually in motion. The formula for running speed is the distance divided by the total journey time minus delays. Time mean speed is an average of individual vehicle speeds, while space mean speed is the distance traveled divided by an average travel time. In this project, movement V1 is taken as our constant road. Therefore, the speed of each vehicle in V1 is calculated. Based on the traffic volume data as shown in the table, the peak interval is at 5:45 p.m. to 6 p.m., where there are a total of 271 vehicles passing through the road during the peak interval. The time taken for each vehicle to pass through 30-meter distance is recorded in the table. Next, we can calculate the time mean speed and space mean speed based on the data in the table. The formula for time mean speed is the total of speed in km per hour divided by the total of vehicle, while for the space mean speed, the formula is the total of vehicle times with the distance and divided by the total time for all vehicles. After the calculation is done, we find that the value of time mean speed is higher than space mean speed. This means the vehicles are slow due to large heavy vehicles occupying the road section for a longer period of time. After that, we conduct the descriptive analysis of speed data including mean, variance, standard deviation, and range. From the speed distribution, histogram and cumulative frequency curve are plotted. From the histogram of speed, we can say that in the hour of 5:45 and 6 p.m., most vehicles pass the reference point moving with a speed of 51 to 60 km per hour only. From the cumulative frequency curve of speed, the median of the speed is 50 km per hour. The 15 percentiles of speed are 30 km per hour and the 75 percentiles of speed are 55 km per hour. From the analysis, the slow speed of the vehicle might be due to the high density of vehicle on the road. Thus, the flow rate of traffic at the junction will be decreased. This situation might cause a traffic jam at the junction.
Next, we go to headway. Headway is a measure of the temporal space between two vehicles. For our project, we use headway as the parameters to evaluate, analyze, and design our traffic control system. Our children junctions have a total number of 6 different traffic movements, but we decided to conduct analysis of headway data for constant direction only, which is through movement along Jalan Besaran in Mas, since this direction involves the highest traffic volume on the major route. Headway data can be obtained by the conducting traffic surveys by the formula that is headway equals to 1 over flow. To obtain reliable results, we divided the complete data for 1 hour into a number of time intervals as shown in the table. In addition, we divided the interval class of headway into 8 classes, each with a 0.1 range. Our data is fairly consistent and does not differ significantly from other sources. After obtaining the headway data for each 15 minutes intervals, we then grouped the data using the 0.1 interval to carry out the descriptive analysis and distribution of the headway. From the graph, we can see that the most of the headway lies between 2.11 to 2.2 seconds per vehicle. And the 15 percentiles, 50 percentiles, and 85 percentiles can be estimated from the cumulative frequency curve. According to the analysis of the headway data, the mean headway for the V3 movement that is along the Jalan Besaran in Mas is 2.31 seconds per vehicle. The largest recorded headway is 2.755 seconds per vehicle. The smaller is 2.055 seconds per vehicle, and the range is 0.7 seconds per vehicle. That is a concerning situation as 85% of the headway data is less than 2.705 seconds per vehicle, indicating that there is less spacing between the vehicles and a rear-end collision could occur quickly due to tailgating. According to the problems that we have observed, it's obvious that there will be serious traffic congestions at the junction of Jalan Bukit Impian 14 and Jalan Bukit Impian during the peak hour. In a nutshell, based on the traffic volume we calculate, we can determine that the overall highest vehicle mix is the car. Moreover, we had analyzed the speed of all vehicles in the movement during peak hour interval at the junction at Jalan Bukit Impian. Lastly, we also studied the headway of vehicles in the junction of Impian Bukit 14 at school time in the movement along the Jalan Besaran in Mas. That's all the presentation from us. Thank you.